Welcome, everyone, to today's Deep Dive. I am so glad you are joining us today.
Yeah.
Because, well, we like to imagine artificial intelligence as this thing living invisibly up in the cloud.
Right, yeah, like this weightless digital ether.
Exactly,
Yeah.
just this place where algorithms float around doing math and answering our questions. But, I mean, the cloud isn't a cloud at all.
Not even close.
No, it is made of heavy metal. It is constructed from these massive industrial-grade liquid cooling pipes, and it's bound together by just thousands of miles of incredibly thick copper wire.
Yeah, it's profoundly physical.
It really is. And
Yeah.
to build that hyper-advanced invisible digital future, it turns out we're entirely dependent on something very old school, blue-collar, skilled manual labor.
It's honestly the ultimate paradox of our current technological era. I mean, if you picture the reality of this industry right now, it's this bizarre hybrid scene.
How do you mean?
Well, on one side, you have these pristine, high-tech server racks stretching into infinity, right?
Right.
Running the most advanced neural networks in human history. But then on the other side, you have raw construction blueprints, hard hats, scaffolding, and like sparks flying from welding torches. And what's fascinating here is that the massive physical infrastructure build-out required for AI is creating a trillion-dollar skills gap.
$1 trillion.
Yeah. We are looking at a physical bottleneck that is actively threatening to choke the entire AI boom. And it's simply because our traditional training systems, well, they cannot pump out qualified human hands fast enough to build the buildings that house the digital brains.
And that brings us to our source for today's deep dive. It's a press release from April 2026, so right now, from a company called EON AI Ventures.
Yes.
They're announcing the launch of something they call their global virtual campus.
Yeah.
But before we get into the whole sci-fi nature of the tech solution they're proposing,
Yeah.
I feel like we really have to isolate the problem first.
We definitely do. We need to move from this abstract macroeconomic idea of, AI infrastructure down to the hard boots on the ground numbers.
Right, the actual workforce crisis. Because the demand for skilled trade labor is skyrocketing in a way that just feels completely unprecedented.
It is. I mean, the underlying logic of that demand is inescapable. The tech industry is currently in a race to build these hyperscale data centers, and they're doing it at a staggering pace.
And these facilities, they house vast clusters of GPUs.
Right, exactly. And a modern GPU cluster runs incredibly hot,
Oh, yeah.
meaning the liquid cooling systems required to keep those servers from just melting down are essentially industrial-scale plumbing and HVAC marvels.
You can't just automate.
No, not at all. You cannot write a Python script to pour a reinforced concrete foundation.
Right.
You can't ask a large language model to physically hoist a 3-ton cooling unit onto a roof, or to, precisely weld the intricate titanium piping of a localized liquid cooling array.
I mean, these are highly complex, deeply physical, hands-on roles. And the statistics in this source document really put the scale of this into perspective.
Yeah, the numbers are wild.
They are. If you look at the growth since 2022, the demand for robotics technicians is up 107%.
More than a doubling of demand.
In just 4 years.
Yeah.
And then HVAC engineers, the people designing and maintaining the systems that keep these massive hot server farms cool, demand for them is up 67%.
Right.
Construction workers are up 30% and welders are up 25%.
And those numbers, they paint the broad strokes of the crisis, but the source highlights a much more acute, severe bottleneck.
Electricians.
Yes, the absolute linchpin of this entire ecosystem. The electrical demands of a hyperscale AI data center are almost incomprehensible compared to, a traditional commercial building.
I can only imagine.
We are talking about single, localized facilities that consume as much raw megawatt power as a small city.
That's insane.
And according to this data, the United States alone needs 500,000 electricians by 2036.
500,000. Just to keep the lights on and the servers humming.
Exactly. And let's break down the causality of that 500,000 figure, because it's essentially a demographic perfect storm.
How so?
Well, we need 300,000 brand new electricians just to meet the new unmodeled demand generated by this specific infrastructure boom.
Okay.
But layered on top of that growth, we have to replace 200,000 existing veteran electricians who are expected to age out and retire in that exact same 10-year window.
Oh, wow. So the industry is facing this massive generational drain of institutional knowledge at the exact historical moment it needs to scale up exponentially.
Precisely.
Well, here's where it gets really interesting. You look at a labor shortage of that magnitude, and Basic macroeconomic theory tells you that the price of that labor is going to shoot up.
Oh, absolutely.
And the financial reality outlined here proves that out, and it is jaw-dropping. I mean, we are seeing young electricians, people in their mid-20s, working at major AI data centers and pulling in massive salaries.
Yeah, the document cites annual incomes between $240,000 and $280,000.
That is a staggering premium for a role that historically has not commanded that kind of compensation so early in a career.
It really reflects the pure desperation of the tech companies funding these builds. I mean, delays in data center construction cost these companies millions of dollars a week in lost compute capacity.
But see, that dynamic is exactly where I have to push back on the core premise of this crisis.
Okay, what do you mean?
Well, if I am talking to a 20-something right now, and I tell them they can make over $250,000 a year without taking on a mountain of university debt, without spending 4 years writing essays, they're going to jump at it.
You think so, yeah.
Right. If the financial incentive is that astronomical, the market should be correcting itself. Why aren't people just flooding into this field? Why do we still have a supply problem when the market is screaming, hey, we will pay you almost $300,000 a year to wire these servers?
Well, the incentive is definitely there, but the mechanism for delivering the talent is broken.
Broken how?
The answer is rooted in the physical limitations of how we teach these trades. The source text points out that traditional training systems are constrained by outdated, highly linear models.
Oh, I see.
Yeah, think about the logistics of training an electrician or a robotics technician today. You need a physical brick-and-mortar trade school. You need physical workshops with specialized ventilation.
Right, and you need expensive, dangerous materials, spools of heavy copper wire, high-voltage breaker panels, industrial robotics arms.
Exactly. And crucially, you need master electricians taking time off the highly lucrative job site to act as instructors.
Oh, right, which they don't want to do if they're making almost $300,000.
Exactly. There is a hard physical geometric cap on how many people you can cycle through a physical classroom in a given year.
So it's a fundamental scaling issue. The demand for the workforce is growing exponentially, driven by the, limitless digital nature of the AI boom. But our system for creating the workers to build it is constrained by the laws of physics and real estate.
That's a great way to put it. You simply cannot build enough trade schools or strip enough master electricians from the field to act as teachers to pump out 500,000 qualified hands fast enough to meet this urgent global need. The pipeline itself is physically choked.
Okay, so that brings us to the irony of the proposed solution.
Yes.
Because traditional brick-and-mortar trade schools are failing to scale, the tech industry is ironically stepping in to digitally train the physical workforce that builds the tech.
It's wild, right?
It is. And this leads us directly to the core of the April 2026 press release from EON AI Ventures and their global virtual campus.
And it is worth noting who EON AI Ventures is.
Right.
The leadership behind this company has 25 years of experience in immersive learning and XR solutions. They have been building digital to physical training bridges for decades.
So they aren't just new to this.
No, not at all. And they have launched this platform specifically designed to tackle national-scale workforce readiness.
Okay, let's unpack this AI plus XR immersive simulation claim because, it's really easy to throw around tech buzzwords.
Sure.
Are we talking about something akin to a hyper-realistic flight simulator? But instead of learning how to land a commercial jet in a crosswind, you are putting together a robotics assembly line.
That is essentially it, yeah.
Like you put on a headset and you practice wiring a multi-million-dollar GPU cluster, making all your rookie mistakes in a digital environment where you can't accidentally electrocute yourself or fry a $1 million server.
The flight simulator is the perfect conceptual anchor for this. Decades ago, the aviation industry accepted that you do not put a rookie pilot in a real multi-million-dollar commercial jet for their first lesson.
Right, the capital risk is too high.
And the human danger is unacceptable. So ELN is applying that exact same risk mitigation logic to high-stakes physical trades.
Makes total sense.
By moving the initial learning environment into a high-fidelity virtual space, you remove the real estate overhead. You eliminate the material waste of cutting copper wire wrong, and most importantly, you completely neutralize the safety risks of physical training.
Meaning the training facility never closes. You don't have to wait for the workshop to open at 8 a.m.
Nope.
You don't have to wait for a supply chain delay on expensive conduit pipe so the student can practice bending it. It creates what is essentially an infinite virtual workshop.
Exactly. The concept of the infinite virtual workshop solves the scaling problem. But, the source makes a very deliberate point about the necessary quality of that simulation.
What do you mean?
Well, we are all highly accustomed to generic AI consumer tools, right? You ask an image generator to make a picture of a dog, and if it gets it 80% right, maybe the paw looks a little strange, that it's generally fine.
Right. It's good enough for a consumer application.
Right.
Nobody gets hurt if the dog has 5 toes in a digital painting.
Exactly. But high-stakes operations, like wiring an enterprise data center that draws megawatts of power, require 100% precision.
Yeah, I would hope so.
An 80% success rate in wiring a hyperscale liquid cooling system doesn't result in a funny glitch. It results in a catastrophic thermal runaway or a massive electrical fire.
So EON's enterprise platforms are built specifically for these environments where precision is non-negotiable.
Exactly.
Okay, but let's look at the mechanics of that. How does the virtual reality actually enforce that 100% precision? I mean, if I'm wearing a headset and holding virtual controllers, I'm not actually feeling the tension of a bolt or the weight of a high-voltage cable.
That's a fair point.
So how does the simulation ensure I am ready to step onto a dangerous, real-world job site?
The mechanism relies on a combination of spatial computing and AI monitoring. The AI isn't just rendering a pretty 3D image of a server rack.
What does it do?
It is running a physics engine that calculates the torque you are applying to a virtual wrench. It is rigorously monitoring the user's biometrics and physical actions in the virtual space.
Oh, wow.
Yeah, it tracks eye movement to ensure the trainee actually looked at the digital safety gauge before flipping the virtual breaker.
That's incredible.
And if you reach for the wrong sequence of wires, the system registers the exact nature of the error and forces a reset. It enforces perfection in protocol, sequence, and spatial awareness before the student ever touches a real wire.
So it is drilling the muscle memory and the safety checklists into the user's brain through pure, unconstrained repetition.
Exactly.
But here's the massive friction point I see with this entire concept.
Okay.
Having a hyper-realistic VR training system doesn't matter if cash-strapped educational institutions can't afford to buy the hardware or license the software.
Right.
And it certainly doesn't matter if a student spends hundreds of hours mastering a virtual environment, takes off the goggles, and then can't actually get hired because the employer doesn't recognize a quote-unquote VR certification.
And this is where EON's initiative moves from being an impressive piece of technology to a viable macroeconomic solution.
Okay.
The press release introduces what they call the skills to jobs to income pipeline.
The skills to jobs to income pipeline.
Got it. The platform is architected so that every single skill taught in the simulation is directly mapped to an existing real-world job requisition from an employer.
Oh, I see.
It is not generalized education in a vacuum. It is a highly targeted, demand-driven recruitment and training funnel.
So they're essentially backward chaining the curriculum. They look at what the tech giants need built next month, and they load that exact schematic into the VR headset today.
Precisely. And to address your point about the friction of cost, they outline their impact share financing model.
Impact share.
Yeah, the document explicitly claims this model eliminates upfront costs for institutions and governments, resulting in zero financial risk.
Wait, I need you to explain the mechanics of how that is even possible. How does a private company deploy millions of dollars in enterprise software licenses and VR hardware to a public institution for free?
It sounds impossible, right?
Yeah. What is the actual financial mechanism of impact share that makes this viable without bankrupting the company providing the tech?
Well, impact share shifts the financial burden from the front end of the education process to the back end of the employment outcome.
Okay, break that down for me.
By linking the training directly to the job placement, the cost of the training platform is essentially subsidized by the downstream value created.
So the employers pay for it.
In a way, yes. Whether that takes the form of the hiring tech companies paying placement fees for fully certified talent, or a revenue-sharing model based on the massive productivity gains realized by the infrastructure developers, the core mechanism is outcome-based. The institution deploying the headsets doesn't have to secure a massive capital expenditure budget up front. They aren't buying the tech.
They're participating in a workforce placement ecosystem.
Exactly, where the ultimate end user, the company desperately needing the electrician, absorbs the value creation cost.
That completely flips the traditional model of education funding.
It really does.
But, the document makes another massive claim based on this model. They state that because of impact share, Institutions can deploy this platform at a national scale in just 30 days.
Yes.
I have to push back hard on this timeline. A 30-day deployment nationwide.
I know, it sounds like a stretch.
I mean, anyone who has ever watched a government agency, a massive trade union, or a state university system try to adopt new technology knows that it usually takes 30 days just to schedule the initial exploratory committee meeting.
Oh, absolutely.
Right? I mean, shipping headsets is one thing, but aligning curriculums, getting instructors trained to use the software, and integrating this into existing bureaucratic frameworks. How is it physically or logically possible to roll out a nationwide infrastructure training program in a single month?
This skepticism is completely warranted if you look at this through the lens of legacy institutions.
Okay.
But if we connect this to the bigger picture, the reason that 30-day speed is cited is because the deployment model bypasses the physical and bureaucratic bottlenecks of those legacy systems.
By not building anything physical.
Right. Think about what dictates the timeline in a traditional national educational rollout. It's securing the state funding through endless legislative sessions, acquiring land, passing environmental impact reviews, pouring concrete, and building physical facilities.
Which takes years.
Decades sometimes. But by removing the upfront financial friction through impact share, and by entirely removing the need to build physical infrastructure, the rollout becomes a pure logistics and software licensing exercise.
I see. So you don't need to spend 4 years building a new technical college wing in Ohio.
Exactly.
You just need to ship a pallet of headsets to a community center or a local workforce development board in Ohio, grant them the software access, and the facility is instantly open.
That's it. The 30-day timeline isn't about perfectly integrating into a legacy 4-year university curriculum. It is about standing up operational, specialized training hubs rapidly.
It just sidesteps the whole system.
Right. It removes the traditional barriers to entry that stall national workforce initiatives. And there is a telling quote in the document from Dan Lajerskar, the chairman of EON AI Ventures.
What does he say?
He defines the AI infrastructure boom as a, quote, once-in-a-generation challenge, unquote. His stated mission is to empower nations and industries to close this trillion-dollar gap. It reframes the stakes of what we are dealing with here.
Wow. So this isn't just a localized problem making sure one tech company can build their new data center on schedule.
No, not at all.
This is about sovereign nations competing to have the physical capacity to host the future of global intelligence.
Exactly. It is an infrastructure race operating on a scale comparable to like the electrification of the globe in the early 20th century or the construction of the interstate highway system in the 1950s.
But faster.
Much faster. The critical difference is that it's happening on a vastly compressed exponential timeline driven by algorithmic advancement, while the labor force required to execute it is bound by linear human constraints.
So what does this all mean for you listening right now? I think it requires a total paradigm shift in how we view the modern economy and the hierarchy of labor.
Absolutely.
We started this deep dive with the realization that the AI boom, for all its digital magic and weightless cloud metaphors, is actually incredibly fragile.
Yeah.
It relies completely on physical infrastructure that requires hundreds of thousands of highly skilled human hands to build. And right now, the world does not have those hands.
No, we don't.
And EON AI Ventures is attempting to hack this massive trillion-dollar physical bottleneck by using the very technologies of the future AI and XR to rapidly train the next generation of high-earning tradespeople.
And doing it with a financial model that bypasses the slow, heavy bureaucracy of traditional education.
Exactly. So if you are looking for the next lucrative, high-status tech job in 2026, it might not be sitting at a standing desk typing Python code into a terminal.
Probably not.
The real tech job, the one paying nearly $300,000 a year, might involve putting on a hard hat, climbing up a gantry, and managing the intricate thermodynamics of a massive data center.
This raises an important question, and it is a philosophical implication I want to leave everyone with today.
Okay, let's hear it.
Think about the mechanical cycle we have just spent this time describing. We are utilizing highly advanced artificial intelligence, operating within high-fidelity virtual reality to rapidly train human beings. And what exactly are we training those human beings to do? We are training them to assemble the massive, physical, real-world infrastructure needed to host even more artificial intelligence.
Oh, wow.
Are we essentially creating a closed loop, a system where the AI has become so advanced that it is now acting as the architect, actively managing its own physical expansion in the real world by training and directing human hands to build its new bodies?